Welcome to web series on machine learning and deep learning. This video series is produced by Analytical Systems, an AI provider company. We'll start the web series by introducing you to data science, the foundations for all technologies based on artificial intelligence. Today we will learn what is data science, how data science has evolved so rapidly and drastically, that it has given rise to new emerging advanced cognitive technologies, of which machine learning is one of them. So first let's define what is data science. Data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from data, which is in various forms, namely structured data and unstructured data. Data science is a broad term for multiple disciplines. Machine learning fits within data science. Statistics and big data forms the other part of data science. Fundamentally, data science allows for artificial intelligence systems to find appropriate and meaningful information from those huge data pools faster and more efficiently. This means that data science helps artificial intelligence systems figure out solutions to problems by linking similar data for future uses. One of the important skills of data science is machine learning. Machine learning is a subfield of artificial intelligence. Machine learning takes the concept of data science one step further by using similar algorithms that big data analytics uses to automatically learn from the collected data. Machine learning is likely the connection between data science and artificial intelligence, since machine learning is the process of learning from data over time through experience. However, it is not the only thing connecting these two together. But machine learning is the branch of artificial intelligence that works best with data science. Machine learning uses various techniques like regression, pattern recognition, data mining, statistics, and other AI techniques. Let us elaborate one by one the four pillars of data science from which machine learning has evolved, namely 1. Statistical analytical methods, 2. Data mining techniques, 3. Pattern recognition techniques, 4. Artificial intelligence. So let's elaborate how statistical analytical methods is utilized for machine learning. Let's start with statistical analytical methods. Statistical analysis is the science of collecting, exploring, and presenting large amounts of data to discover underlying patterns and trends. Statistical analysis is the process of collecting and reading data so that one describe past behavior and characteristics and predict future ones. Statistics is the study of collecting, analyzing, and studying data and come up with inferences and predictions about future. Statistics also deals with designing surveys and experiments in order to get quality data which can further be used to make estimation about the populations. Statistics is used to summarize numbers, for example, finding out descriptive statistics like mean, median, mode, standard deviation, variance, percentiles, testing hypothesis, etc. Statistical learning involves forming a hypothesis, that means making assumptions that are validated before building models. Statistics is more concerned about the inference that can be drawn from the model. Statistics is about converting the data into aggregate numbers which help understand the structure in data. Statistics is useful for solving problems that involve probability such as forecasting. Some of the popular statistical methods include inferential statistics and descriptive statistics. Statistical analysis is the use of probability distribution to solve problems. The following are few statistical analysis techniques that are commonly used in business scenarios, namely 1. Cohort analysis, the use of behavioral analytics to study behavior of a particular group of people, known as a cohort. 2. Data dredging, a brute force method of data analysis that tries to match known statistical models to large set of data, at risk of finding patterns that are meaningless noise. 3rd, data mining, the analysis of a large repository of data to finding meaningful patterns of information. Typically starts with a hypothesis that you want to confirm with data. Fourth, probability distribution, a function that predicts the result of a set of experiments over a large sample space. Fifth, regression analysis, a statistical method of investigating the relationship between the variables. For example, regression analysis can be used to plot the relationship between two variables on a graph. Sixth, statistical model, a probability distribution constructed to support data analysis. Seventh, population, a set of observations that share a set of properties. For example, the set of all coffee drinkers in India. Statistical analysis and data mining addresses the broad area of data analysis, including data mining algorithms, statistical approaches, and practical applications. Topics under statistical analytical methods include A. Solutions for problems involving massive and complex data sets. B. Solutions utilizing innovative data mining algorithms and or novel statistical approaches. C. The objective evaluation of analysis and solutions. So this was about statistical analytical methods. Next, let me explain about data mining and big data techniques used for machine learning. Data mining is the practice of examining large pre-existing database in order to generate new information. Data mining is the process of sorting through large data sets to identify patterns and establish relationships to solve problems through data analysis. Data mining also involves analyzing hidden patterns of data according to different perspectives for characterization into useful information, which is collected and assembled in common areas such as data warehouses. For efficient analysis, data mining algorithms facilitating business and decision making and other information requirements to ultimately cut costs and increase revenue. Technically, data mining involves the process of discovering patterns or relationships in large areas of related database. The major steps involved in data mining process are extract, transform and load data into data warehouses, store and manage data in multidimensional databases, provide data access to business analysts using multiple application software, present analyze data in easily understandable forms such as graphs. Also, data analytics enable data scientists, predictive modelers, and other professionals in the analytics field to analyze large volumes of transaction data. They can also use big data analytics to analyze data which might not have been discovered by conventional business programs. This includes social media content and social network activity reports, data from sensors connected to the Internet of Things, customer emails and surveys responses, web server logs, and internet clickstream data. Big data analytics refers to the strategy of analyzing large volumes of data. That means this big data is gathered from a wide variety of sources, including social media networks, videos, digital images, sensors, and sales transaction records. The aim in analyzing all this data is to uncover patterns and connections that might otherwise be invisible, and that might provide valuable insights about the users who created it. Through this insight, business may be able to gain an edge over their competitors and make superior business decisions. Data mining, also known as data discovery or knowledge discovery, is the process of analyzing data from different viewpoints and summarizing it into useful information. This information is used by businesses to increase their revenue and reduce operational expenses. Some of the popular data mining methods include estimation, classification, neural networks, clustering, association, and visualization. Examples of data mining and analytics include market trends, customer preferences, hidden patterns, and unknown correlations. So this was all about data mining and big data analytics. Now let us go to the next fundamental pillar of data science, that is pattern recognition. Pattern recognition is essential to many overlapping areas of IT, including big data analytics, biometric identification, security, and artificial intelligence. Pattern recognition can be defined as the classification of data based on knowledge already gained or on statistical information extracted from patterns and or their representation. One of the important aspects of the pattern recognition is its application potential. Pattern recognition is the automated recognition of patterns and regularities in data. Pattern recognition is the ability to detect arrangements of characteristics or data that yield information about a given system or data set. In a technological context, a pattern might be a recurring sequence of data over time that can be used to predict trends, particular configurations of features in images that identify objects, frequent combination of words and phrases for natural language processing, or particular clusters of behavior on a network that could be indicate an attack among almost endless other possibilities. Pattern recognition involves classification and cluster of patterns. In classification, an appropriate class label is assigned to a pattern based on an abstraction that is generated using a set of training patterns or domain knowledge. Classification is used in supervised learning. Clustering generated a pattern of the data which helps in decision making, the specific decision making activity of interest to us. Clustering is used in an unsupervised learning. I'll touch upon supervised learning and unsupervised learning in later part of my web series. Pattern recognition possesses the following features. 1. Pattern recognition system should recognize familiar pattern quickly and accurate. 2. Recognize and classify unfamiliar objects. 3. Accurately recognize shapes and objects from different angles. 4. Identify patterns and objects even when partly hidden. 5. Recognize patterns quickly with ease and with atomicity. Applications of pattern recognition: image processing, segmentation, and analysis. Pattern recognition is used to give human recognition intelligence to machine, which is required in image processing. Computer vision is another pattern recognition which is used to extract meaningful features from given image, video samples, and is used in computer vision for various applications like biological and biomedical imaging. Third, seismic analysis is also another pattern recognition approach, is used for discovery, imaging, and interpretation of temporal patterns in seismic array recordings. Statistical pattern recognition is implemented and used in different types of seismic analysis models. Fourth, radar signal classification or analysis is also a pattern recognition, and signal processing methods are used in various applications of radar signal classifications like AP mine detection and identification. Fourth, speech recognition is also another pattern recognition. The great success in speech recognition has been obtained using pattern recognition paradigms. It is used in various algorithms of speech recognition which tries to avoid the problems of using a phenomenon level of description and treats larger units such as words as pattern. Lastly, fingerprint identification is another pattern recognition. The fingerprint recognition technique is a dominant technology in the biometric market. A number of recognition methods have been used to perform fingerprint matching, out of which pattern recognition approach is widely used. Now let us move to the next fundamental pillar of data science utilized by machine learning algorithms, that is artificial intelligence. Artificial intelligence refers to the simulation of human brain function by machines. This is achieved by creating an artificial neural network that can show human intelligence. Artificial intelligence is an area of computer science that emphasizes the creation of intelligent machines that work and react like humans. Artificial intelligence must have access to objects, categories, properties, and relations between all of them to implement knowledge engineering. Artificial intelligence is a rapid advancing technology that may soon have significant drastic impacts on our everyday lives. Artificial intelligence traditionally refers to an artificial creation of human-like intelligence that can learn, reason, plan, perceive, or process natural language. Artificial intelligence is a field of study which studies how to create computing systems that are capable of intelligent behavior. Some other texts define as the study or design of intelligent agents. Here, agent is a system, that is software or hardware, that perceives its environment and takes actions that maximizes its chances of success. The collection of big data and the expansion of the Internet of Things has made a perfect environment for new artificial intelligence applications and services to grow. Applications based on artificial intelligence are already visible in healthcare diagnostics, targeted treatment, transportation, public safety, service robots, education, and entertainment, but will be applied in more fields in the coming years. Together with the internet, artificial intelligence changes the way we experience the world and has potential to be a new engine for economic growth. In the next slide, we will explain in detail about artificial intelligence and its types. Now, coming to the core part of the topic, that is machine learning, let's briefly explain the concept of machine learning, a subset of artificial intelligence. Machine learning is a subfield of artificial intelligence. Machine learning is a scientific study of algorithms, statistical models that computer systems use to progressively improve their performance on a specific task. Machine learning is a type of data mining tool that designs specific algorithms from which to learn and predict. In 1990s, Arthur Samuel, a pioneer in the field of artificial intelligence and computer gaming, coined the term machine learning. He defined it as artificial intelligence is a field of study that gives the ability of the computer for self-learn without being explicitly programmed. That means imbuing knowledge to machines without hardwired programming it. Machine learning is mainly focused on the development of computer software, which can self-learn to develop and adapt when exposed to new data. Machine learning algorithms build a mathematical model of sample data known as training data in order to make predictions or decisions without being explicitly programmed to perform the task. Machine learning studies algorithms of self-learning to do tasks or jobs at hand. It can process massive data transfer with learning algorithms. Common applications of machine learning are found in everyday life today. That is, machine learning algorithms are used in application of email filtering, detection of network intruders and computer vision, speech and natural language processing, face recognition, image classification and object detection, car driving, playing complex games like AlphaGo, control strategies like control engineering. In our next video, we'll discuss about the types of artificial intelligence and its subcategories. Till then, have a nice time. Bye.